Today, I want to show you how you can set up Login with Apple inside of your Lovable mobile application using Supabase and Despia. It's super simple, so let's get right started with that. Now, first of all, you need to note that you actually need to use Apple JS, and you can't fully rely on Supabase's pre-built Apple Authentication plugin, because what it does is the pre-built one redirects from a Supabase URL to an Apple URL, meaning the Supabase URL is in the middle, and it actually kills some of the native workflow that triggers this beautiful modal to pop up on your site. So in order to get that modal to pop up on your site without having to do a redirect, you need to implement Apple JS. So let's get right started with that. As you can see, I already have my application linked inside of here. It's actually an old version of the application. So I can just go on test flight and I'll be able to update that. And because I have updates over the air, I'll be now able to just click on publish and Lovable, and then we'll be able to test this and see, how it works natively on the device in the native environment. If you see, if I open that again, it'll be a new project that we're working on today, which is blank, which, you see, obviously is blank and Lovable. So now we can get started with the setup. So the first thing is we want to connect with Supabase. So I need to connect to my Supabase project inside of Lovable. Now I already have an Apple Auth project, so now it's connected. That's perfect. So now we need to start, or, Lovable is already thinking. So it's saying it looks like you haven't created any tables in your Supabase project yet. Your app is now connected to Supabase. You can now work with a fully featured backend and powerful features that make your app truly functional and all of that. So now let's set up login with Apple using Apple JS. I need to use Apple JS. It's mandatory for my use case. Right? And now let's go into chat. So we have Lovable come up with a plan for the implementation. That's going to save us credits, and it's going to give us a guaranteed result once we implement the plan that it will actually work the way we want it to work. So it says, I understand you need to implement Apple sign-in using Apple JS, the JavaScript SDK, rather than the standard OAuth flow. This is a specific requirement that needs careful implementation. Let me first examine the current authentication setup and then understand what Apple JS integration entails. And now it looked up some tools here. And now let's check the official Supabase documentation for Apple Authentication and see if there are specific considerations for using Apple JS. And then, it looks through all the stuff. So now it tells us about the auth flow, right? An Apple JS approach, your requirement, uses Apple's online JavaScript SDK, requires loading Apple script, uses Apple ID auth init and Apple ID auth sign-in methods. Gives you control over the authentication flows, is exactly what we want, returns an identity token that you need to verify on your backend. The nice thing about Apple JS is we can do a full OAuth procedure using the native modal without having to do a redirect. We're doing the redirect with Supabase will break and will not look nice in a native environment. And the standard OAuth flow is just essentially doing a redirect to a different URL, which it's not the nicest way. And it takes some time because it has to be loaded and all that. So now it has an implementation plan. Since you need Apple JS specifically, here's my recommended approach. Apple Developer Account, configure Apple Developer Account with proper service key ID, and team ID. Set up the JavaScript origins and redirect URLs. Generate the necessary certificates and keys, front-end implementation, add Apple's JavaScript SDK to the HTML head, create an Apple sign-in button component, initialize Apple JS with your configuration, handle the Apple authentication response, and then it implements all the other stuff with a database and all that. So now let's start implementing the plan. And now Lovable will begin working on implementing the plan. Now, while it implements the plan, that'll take some time. I can already walk you through how to set this up correctly on your Apple developer account. Now, we need to go inside of an Apple developer account. So you need to get one if you don't have one already. And you have to go to identifiers. And we're going to create a new identifier that will be a service ID. And we're going to continue. And now the description of the service ID will be, let's say, my app, Apple auth, right? For Apple login. And then the identifier will be my app name. In this example, it's com.despia.myapp.apple auth. Something like this, right? It's just reverse domain style. Okay. And it will be very simple to your bundle ID if you already have a hybrid native application. So let's continue with that and let's register. So now we have this my app Apple auth service key, and we need to open it. And we need to set up sign in with Apple. And now we need to configure this. So now this needs to be linked to our core parent app ID. So if you already have a native app ID that has this capability, you will need to link it. I do not already have one, or I have one, but I need to upgrade it. So we're going to do that right now. So let's continue. And we can actually continue until we set that up. So we have to go back to our app IDs. And I now have to look for my app, which is my app's name. Very creative. And I now go to my app core bundle ID. That is what you already have registered in Despia, or you can just register a bundle ID following the instructions if you haven't already. And you now need to enable the native capability for login with Apple. So that should be about right in here. And now we have server-side notification endpoint. We don't need that yet. It's optional though to implement. And then enable with existing primary app ID, enable as primary app ID. We'll just keep that enabled. Okay, and let's save that and let's update the bundle ID capabilities. Okay, now we can go back to identifiers and we now go to our service IDs here. And now we go back to my app, Apple auth. We're going to click on sign in with Apple, just like that, and we're going to configure. And it's now going to be linked to our core bundle ID for my app core bundle ID. And now we need to add domains and subdomains and the return URLs, right? So this is where it gets a little bit interesting, because now we need to go back into Lovable and we need to fill out all those team IDs and continue with the procedures. But let's just first look at our published Lovable site, right? That's our URL, and you also want to put in your custom domain in there. But let's put this URL inside of here as our domain. And then I'm also going to put the preview in here so we can also test login with Apple. We'll probably have to open the preview to get that. And let's also put that domain here for the preview. Oops. Let's get that domain for the preview. Perfect. Let's put that back into Apple. And we have that now inside of here, comma separated. And then the return URLs, we do not have a return URL, but I'm going to create one. So the return URL will be https:// and we'll need to keep that in our mind, /OAuth/Apple. That will be our OAuth proxy URL where it should return it to. So just keep that in mind, because usually when you do OAuth procedures with Apple JS, there will be a return URL, because when Apple JS was successful, it will go to a page and then inject the token. Most of the times, it could be that we don't need this in the specific Apple JS implementation. My knowledge is not up to date to be able to know that. But most of the times when you're doing OAuth procedures, after the procedure, you go to a different URL so you can run a workflow on page load to get that token that's attached to it, send that to your server, store the login. So in case we need that, it will be /OAuth/Apple. In case we don't need that, that's fine too. So let's go on done. Let's continue in setting up this service here. And now we're going to save that. Perfect. So now we have that saved and we have that all set up. So now Lovable asks us for our Apple team ID. So we just need to copy the team ID from the top right corner of our Apple developer account. That's the team ID. And I'm just going to paste that inside of here. As you can see, that's our team ID. Let's submit that. It's the UR one, right? Let's see. Yeah, that is correct. So now Lovable is thinking, and now it needs the Apple key ID. So let's look at the description that it says for the key ID. Let's look at that again. So we don't have a key ID for that here. So let's ask Lovable in chat mode, where do I get that? Where do I get that? Because we don't have the key yet. We do, though, have the service ID, which is kind of like looking like a bundle ID. So let's ask Lovable. I can see you need to provide the Apple key ID for Apple sign-in integration. Let me explain where to get this and the other Apple credentials you'll need. So if now look up all the stuff, and let's see. The team ID, we already have that. I know that. Okay, but it seems that we need to actually create a new key specifically for login. So let's wait till it finishes that. Okay, so let's look at the key ID. In Apple Developer Console, go to Certificates, Identifiers, and Profiles. Click on Keys. Okay, so it just wants us to create a new key for sign-in with Apple. Okay, and then we register. Okay, I can do that. Okay, so go back to all identifiers, and then we go to Keys. And now we actually done that before. Okay. Sometimes you forget the stuff you know. And let's do, the key name will be My App, Apple Auth. And then I'm going to go and do sign in with Apple. I got to configure that. It needs to be mapped to our parent ID, so our core bundle ID. And we're going to then save that. And then I'm going to continue. Now I'm going to register, and this will give me the key ID. So now let's go back to Lovable, and let's go a little bit more up here. Oh, that expired. So let's say I got it now. Let's keep going, right? So let's keep going with Lovable and setting this up. And then we just need to paste in the key ID that we are able to get right from here. And then we also need to download the key. That is a file upload. And never forget that key, because you can only download it once, and once it's gone, it's gone. So it's quite important. Let's update that. That looks fine. Let's submit that. And now that will create that on our backend, so we can just chat with Lovable and implementing that. Now we need the Apple Service ID. Now the Service ID, if you don't remember, was actually, let's duplicate the tab. That was the thing that we generated a step earlier. So if we go to the identifiers and we go to the Service IDs here, we'll see that there are Service IDs, and this is the Service ID here for our login with Apple implementation for that bundle ID. So we're just going to copy that, and we're going to paste that inside of here. That looks correct. And let's submit that. That is the service for the authentication service that we're going to create inside of our application. Now we need the private secret key. Now, Apple private key, this is something that we can download. So what we are probably going to do is we're just going to download the private key, and I'm just going to drag this to my desktop, and you're just going to double click on it, and then we can just get that key from Xcode. I don't mind people seeing that. So let's just copy that, begin private key, end private key. Okay. And now we have that. And then we're just going to put that into Lovable. Yeah, that looks good. Perfect. So now Lovable is going to take a look at that, and we should be able now, to approve some of the changes. So now I'll create the database migration for user profiles and then implement the complete Apple sign-in system. So we can take a look at the code. It's going to implement the role policies and all that. So let's say we approve that change. Let's approve that. And now it's going to continue with some of the next steps to set this up. Nice thing about Lovable is does all the work for me. Usually I would be typing and you would be hearing lots of typing sound, but I just have to type and give some input and, I just have to lead where it should go, rather than me having to do everything myself. So it's pretty convenient setting apps up like this. So now it's editing some of the edge functions, as I can see here. Yeah, okay. And we'll just wait till that finishes. In the meantime, let's make sure we don't need to continue on there because we didn't edit anything. Let's double check. No, we didn't edit anything. It's already configured. Website URLs. Yeah, we don't need to touch that. You're good. Their UI sometimes is a little bit confusing at Apple. We close that. That looks good. Let's go back to Lovable. Okay, now it's editing a bunch of files. It's doing all the edge functions and then also updating the components and all that kind of stuff. So it does actually right now for us most of the heavy lifting in setting all of that up. So we can just lean back. Now, one thing to note that we're not doing that, probably is tempting many people is if you go to Supabase, they have this authentication tab. And if you go to sign-in/providers, you'll see that there's already Apple built in. We're actually not going to set it up through this because this gives us a callback URL that is a Supabase URL. And this is what I mentioned earlier. This kills the whole nice native feeling vibe of the login procedure because you are working within an iOS application and with an Apple SDK, and then there is a redirect to Supabase in the middle. That just kills this whole beautiful communication from Apple to Apple, and is going to make the process feel janky and cheap. So we're not going to do that. We're going to implement this custom implementation that we've been working on in this video. That is pretty much the whole point of this video. So that's just something to note that is important. So as you can see, it's going all in here. Perfect. I've implemented the complete Apple sign-in system with database backend and front-end components. So let's ask it, is this ready to test? Is this ready to test? Okay, let's actually try opening the preview URL and let's go and open this in Safari, because when you are working with Apple Auth, the best way to test it is Safari. There isn't anything better than that. So let's go to Safari and let's try that in Safari. If I go to continue with Apple, it actually opens the native modal. This is what I'm talking about. If you do a redirect to Supabase, the whole thing in the background will be white and it's going to look shitty and crappy, excuse my language. So this is a nice native integration for it. So now here comes the beauty. Let me show you the beauty. If we now go to our native application and we have to publish, I forgot to publish. So we just need to publish because our app will be still white until we click on publish. Despia has updates over the air. So it'll be all nice. And I think this whole thing, there's a chance that it works. There's a chance that it doesn't work fully, but at least the native modal will work. There you go. Let's close that. So let's close the application and open that again. So let's close that. Oh, it seems like my broadcasting stopped. Let's connect that again. Excuse me for the technical errors here. Oh, there you go. Now it's connecting. Look at that. The app just gave up. But let's go back here in opening the application through test flight, which is the way we test our applications. And now you will see we have this continue with Apple button. The interface of the application was updated. So now when I click on continue with Apple, you see how we're getting the native login with Apple modal inside of our application without any super ugly redirects, which usually happens when you do those kinds of implementations. So let's try logging in here. Ooh, I just opened my Bank of America card. Let's try that again. Let's go and continue. Now I'm doing Face ID to log in here. And now sign up not complete. So while we get the modal, there are some technical errors that happen. Now, the good thing is we got the native modal. That is cool. Now, the flow isn't fully configured, but this is why we have Lovable to help us set this up production ready. Now, your service ID is hard-coded, missing Supabase URL configuration. So there are some things broken. Let's say when I click on, continue with Apple, I get the native modal, but when I do Face ID, I get an error. Please create a plan to fully complete the setup. And let's send that to Lovable so it creates a plan to fully integrate native login with Apple. But super cool. I love the fact that it just so nicely shows the native modal. That is really worth it to me. The native modal, I mean, that is just a beauty. It's a beauty. Nice. So now Lovable will be working on that. And then we can integrate some of the other stuff attached to it. So let's see. Now it's looking at our Supabase implementation here. So it actually reads all the stuff, and it's looking at our edge function logs. So the nice thing about Lovable, it really nicely integrates with Supabase, meaning it can read everything that happens on your backend to troubleshoot, get all the error messages. So here's what it came up with. Based on my analysis, here are the critical changes preventing successful Apple sign-in authentication. Hard-coded client ID. The auth.txt TSX file has your service ID. Yeah, that'll not work. Token misconfiguration. The Apple sign-in doesn't match the backend expectations. Okay. So now what we want to do, add redirect URLs. Okay, let's say perfect. And keep in mind, we said redirect URLs, right? Let's say perfect. We need the redirect URL to be /OAuth/Apple, where the second path is the dynamic auth provider name, so it can be scaled later on to be working with multiple providers, right? You always want to think a little bit, not the redirect URL, want to think a little bit more scalable, right? You don't want to hard code that /auth/Apple page. You can do /auth/dynamic parameters. So you can have /Google/Apple/Microsoft/ crypto wallet thingy, whatever you want to do, right? So it will make that dynamic so we have it a little bit more scalable. So now it's setting that up, and Lovable is now going into our application, doing all the appropriate changes. My screen mirroring stopped again. I shouldn't close my iPhone, just it's muscle memory. Let's see. Let's connect that back here. Ooh, no, it doesn't. Okay, we'll just wait while Lovable comes up with that. Perfect. And now it creates the plan. So we're just going to implement the plan. And while it implements the plan, let me get my screen sharing to work again. That would be beneficial. So let's look into that. So Lovable is now creating the router page. And it's now setting up the scalable OAuth infrastructure and all that kind of stuff. And my iPhone is coming back to life for screen sharing. Beautiful. Okay, so we're now at the application. So now, as you can see, Lovable is doing the changes. We can take a look at the code that it changed. And you're seeing that it creates the native providers here dynamically. And then that it kind of like does like the completing redirect. Now, let's say on the callback URL, make it look very nice with a native looking
loader, right? Because you want to do the page, make it look nice, because it's quite a detrimental change. But let's just update it, and then we're going to test if the workflow now works. Well, it's going to make the whole thing look pretty, right? So it's now updating this on the Lovable side, and then once it's fully updated on Lovable, it'll be fully updated in our native application. So the only thing we have to do is close the application and then open it again through TestFlight or through the app that's on there. So now if I go continue with Apple, it'll open the native beautiful modal. I'm going to go on continue. I'm going to scan my face, and sign up is still not working. So we'll need to take a look at that. There's some debugging to do. There's always debugging to do. OAuth is a tricky thing. But let's go back here, close that. And now we say I added a beautiful native looking loader for the OAuth callback page. Okay, let's give it the benefit of the doubt and let's update it again. And then let's also test this in Safari to see if it works in there, right? Because sometimes if it doesn't work in one environment, you want to try it in another environment because you can get the console logs and all the stuff. So let's copy that here and let's get the URL, open this in the Safari browser. And now what we're going to do is we're going to inspect elements and we're going to look into the network tab probably. Yeah, let's try the network tab. So let's put that here. Okay, so when we continue with Apple, it's actually not doing a network request. So let's move back to the console and clear the filters. So now I'm going to continue with password. Okay, and now the signup is not complete. Okay, so we have initial session undefined. That's a log that helps. Okay, so let's say, now I can type. When I log in, I get, and I'm going to put the error in there. This results in the Apple auth not going further than the native modal just popping up. After Face ID or password, I get an error message. Okay, and now we're going to go back into chat mode so we can use the AI to reason about this, come up with a plan, and then take that plan and implement how it applies. Now, what I do assume is, let's look at the text files here that are initializing the native OAuth. Redirect to, I don't like that it redirects to localhost, but we'll see. Let's see, let's just look for com dot. It's not in the text files that it's changed, so I think it may have still hard-coded the old one. But let's see what the chat is telling us, what's happening. So it's still thinking. We can actually just look at the code files here, because I do have some assumptions. So let's look in for Apple and components, Apple sign-in. Okay, that is our component. And let's see. Response type, code ID token, email, form post, and we are doing data session URL, redirect to the session URL to establish the session, redirecting in. So where is our ID coming from? It may be loaded from a different thing. Let's see. Very indestructible response, window.appleauth sign in. We're not providing the ID that will tell Apple which application is trying to do Apple Auth. At least I can't find it in here. So that may be the whole thing. It did seem though like Lovable kind of like got stuck at something. So let's see if we can refresh the page and let's just copy the message and let's put that in here again. And let's send it to it and
Yeah, let's send that to it and let's have it take a look at that. Now, those things, they're always a little bit tricky when it comes to OAuth, when it comes to setting up those things. But I think we're probably missing a line of code, and that is why it doesn't work. And I think it's just one of those slight AI oversights where it's just kind of like not seeing the forest because of all the trees. Even though, it's very close to it. But we'll see. It still seems to be thinking. I hope that I didn't run out of my credits. No, I should have enough left. So we'll just give this a try. Let's try publishing it again. Maybe that'll fix it. Still thinking about stuff. So how about we reload the page? And let's just copy this, make sure we specify chat, and let's just put this in here. Oh, it's still thinking. So it actually continues where it stopped. Let's then cancel this message here. Oh, now I think maybe there was a temporary API issue with Claude or ChatGPT or whatever model they're using. But it seems that it started to go again. So it was thinking for quite a while. Okay, yeah, now it's doing stuff. So it's thinking for 9 seconds, looking at this file. This is probably the core file where the error is happening, based on my assumption. Also, the toasts are way out of any safe area, so we need to add native safe area to that. But I'm just saying that because I'm seeing that it loads like the toasts, but one thing at a time. So we're doing the Apple on success. We're calling the native Apple code ID token. I do think it's missing the service ID. That has to be what's happening, because I'm not seeing any way how it loads the service ID. Like service? Like, I don't see it in here. I don't see it loading the service ID. I think it's very likely that that will be the issue, which we'll see. It is still thinking for a little bit and reading files. Let's take a look at that here. We have the Supabase URL. We are getting the service ID on the backend. I do strictly think if we have the service ID on the backend and we don't have it on the front end, and then it will probably be like, hey, yeah, I know who I'm listening for, but who is telling me this, So I think that could be it, that Apple doesn't know which it is to initialize, but we'll see. So it's still thinking. Is there something that we can do in the meantime? Let's check Supabase. Did something happen with the Apple integration? I think we didn't use the Apple. Yeah, we didn't use the Apple integration. So you don't need that if you want Apple Auth to have this nice native modal. And then Despia, there's actually nothing you have to do because the runtime already interprets things the way they have to be interpreted. We can actually go out of these keys here. We don't need them anymore on the backend. And then if we do like continue with Apple on a Windows computer, oh, this actually helps us. It says invalid client. This 100% tells me that it's the client, the client service ID that wasn't initialized. So this actually helps. This is really good because you see, oh, this is good. This is good. You see how the client ID says your service ID as like a fallback? I guarantee, I bet with you that I can actually fix this manually. I just need to find the file that has this thing in it. Okay, so there's this file here, your service ID. Oh, where the heck is it? Your service ID. Let's go on search in the file. Your service ID. It's 38. It's line 38. Okay, it's in here. Yeah, you see how it puts your service ID inside of here? I can manually fix that. So how the heck do I edit stuff? Oh, I can just edit stuff inside of here, right? Okay, put that inside of here. I don't even need it to implement its plan. Where it says your service ID, it shouldn't say your service ID on there. But it should be our actual service ID, right? It can't just be like your placeholder ID. Imagine it's correct. So we're going to go to our service IDs and we're going to copy the service ID, that didn't work, for the application that we have just generated. And we're now going back into Lovable and we're just putting that in there. So sometimes actually testing all your native stuff in the browser can help because it'll give you different error messages if you're in Chrome and it's not native to the system, so you can get more details out of stuff. So let's save that. And I think we don't even need it to fix it for us and spend credits. This is probably such a simple fix that we could implement ourselves. So let's update this in Lovable. And let's just wait till that finishes, and then I'm going to test it right in my native device here. I'm not going to get that ready already. Yeah, make sure that the application just opens newly. Yeah, that was updated. Let's go on My App. Perfect. And now I'm logged in. Let's do continue with Apple. And I'm now going to go on continue. I got Face ID. Look at that. Now login still not complete. So we'll see what's happening here. So let's open that URL again, and let's go and continue with Apple. And then now it says invalid request URL. I will bet with you that it probably also goes to an invalid request URL. So let's see, what's the redirect URL? The redirect URL is auth/callback. So you see how AI sometimes loves to hallucinate, but if we're in the driver's seat and we just, kind of like guide it where to go, it's going to be able to be very helpful. But you need a little bit of understanding of how to debug things, and that's why we're doing those videos here. So let's say I fixed it. The service ID was hard-coded. Okay, so now that'll solve the problem. Now I will guarantee with you that if we look at the code again, and where the callback happens, so we should have a file somewhere in here saying auth callback, and that page would probably be the auth callback page. So we probably want to look globally in the project, because there was this auth/callback. Okay, so now you see how it's line 40. Okay. You see how it tries to go to /auth/callback? Remember how this doesn't exist. It needs to be auth/Apple. Remember, because auth/callback is not registered. And then line 38, we already fixed that, right? So now line 40 is also fixed. Let's save that. Right? So always make sure that when it doesn't work with your OAuth principles, the only reason OAuth doesn't work is because it's either you're not using the right credentials to initialize the session, or you're not redirecting to the providers that are registered. Like, AI does auth/callback, and then you have to go though to auth/Apple, right? And then there is a mismatch. So let's try if this actually works. I assume Chrome is probably the best way to test this. Now it says invalid request URL. So now we're going to auth/Apple, but we are going to view starter lovable app. Okay, so let's go auth/callback. This needs to be auth/Apple. Let's tell Lovable I fixed all. Let's try again. Okay, so let's try that again. And now Lovable is thinking about it. So everything on our end should be fine now. So it's still saying wrong URL, and that is very likely because we have this URL. And let's go to Claude, and let's just ask Claude to URL decode it. So URL decode this URL. So it's a little bit simpler to look at how the URL actually needs to look that we're redirecting to. So as you can see, we're doing a redirect URI to HTTPS clearview lovable app/Apple, right? So, and then we get this response code here, which is the token and the frame ID and all the stuff that we use to finish the login, right? Now, what we want to do, type code ID, token, scope, name, frame ID. Okay, we'll see if that gives us sufficient information, but we have this URL. This URL should be reachable. It doesn't exist in our project. could be the problem that this URL doesn't exist in our project, you know? So it's all about debugging. So let's go back.
Okay, let's say what Lovable is saying.
Redirect URI is still set to be OAuth/Apple.
But the edge function redirects. Okay. Fix it to be OAuth/Apple. Okay, and then we're just going to send that.
And let's actually try the URL again, right? It's going to auth/Apple. Yeah, I did overlook the little O. But if we go to OAuth/Apple, that actually works. That is a valid path. It doesn't go to an invalid URL. So the problem is actually that we have a little mismatch where I thought we should make this auth Apple, but on the back end it set it up as OAuth/Apple. On the front end it did auth/Apple, and then it just doesn't go together, right? And then with Apple, we registered it to be OAuth/Apple, and then Apple is like, what's happening here, right? So with that being said, Lovable will be able to fix that with us in just a snap. So as you can see, it now goes to OAuth/Apple. That may be actually the thing. Let's try updating that. And I think we're going to get very close to having this now successfully implemented here after creating a bunch of new tabs. Let's close all the tabs that we don't need. Okay, let's try opening this again. Okay, and let's go on continue with Apple. And now I'm pleased to announce that it goes to the correct page, meaning this was successful. So if I now start my little screen sharing thing again, that always likes to time out when the phone goes on standby. So let's enable that again so we can see the screen popping up here. There you go. Perfect. And let's open our application. We got to close it and open it again to refresh the whole thing, right? And now I can click on continue with Apple. I'm getting this beautiful native Apple element to log in. How great does that look? Just being in the background, like your application slightly fades out and you got that. And oh, I'm always double clicking and I'm always opening my credit cards. It's such, okay, we got to click on continue, not double click. I'm not purchasing something on the App Store. And now you see it says signing in. And now we should be signed in. Oh, that was a funky loader. But now you see, welcome to Lovable. Hello, my email. You're successfully signed in. So now we can combine this with some other native functionalities that Despia provides. Because now that the user is logged in, I should be able to close the application, open the application again, and be on the logged in site, which I am, right? I'm logged in. Now that I'm logged in, I can do an in-app purchase as the logged in user, right? Because I should be able to get my Supabase user row ID. So let's say, can we add the Supabase, this is just for debugging purposes, but Supabase user row ID on the login page in a text input for debugging, right? This will show us the user ID of the user that is created in our Supabase database. So to verify that what I'm telling you is actually true, let's look at our authentication database, and you will see that I was just created here using actually the email provider, but it happened through login with Apple. So what it does, we actually used Apple JS to create a proxy for Subabase's email login. So this user ID is linked to the email, but Apple JS provides the email. So meaning the user can now log in with their email if we want to have login with email and still get into their account, but they can also use Apple JS to log in as their email account. Now we could also then add a column in this database or relate it with another database to link them with their Apple key ID, because every Apple account also has their own ID to make it a little bit more scalable. We can look into that at the end of the video, but let's take a look at in-app purchases and how we can handle them now that we let the user in through their email that is linked to their Apple account.
So let's add Supabase example ID. So we just have like this little input here. So let's publish the application, and then we're just going to, oh, there's a security warning. We probably want to take a look at that. Leaked password protection disabled. So let's look into that. Let's see. Leaked password protection is currently disabled. Recommendation. We probably want to enable that for leaked passwords. So those are things that we can do once we're done with the implementation. Okay, so now we should be able to publish this, and let's go to the application, close that, open it again. And now what we can clearly see is that it didn't update yet. So I added a text input to show the Supabase user ID. Let's try closing that and open the application again. And let's see if it added it. I don't see it. It should be on the welcome Lovable page. Make sure it's, oh, no. Make sure it's on the welcome to Lovable page. I do guarantee that it probably added it to the wrong page. Yeah, it's on the auth. I think it probably added it to the auth page. I'll move, yeah, you see it needs to be to the index and not the auth page. So the index page is the page for logged in users, not the page where you are logging in, because it doesn't help us getting a non-existing user ID on the page that is for users who are not logged in, right? It should be on the page for users that are logged in, right? So you can see it's now moving it onto the correct page. So now it's saving the changes. We can now publish this again, update it. Again, we got updates over the air. So that'll update that in the mobile application. And we should now be able to see the Supabase user ID. So let's try that. It's updating it. I can close the app, open the application again, got updates over the air. And now we're seeing the Supabase user ID for debugging. This is actually very important, because with this user ID, we can now integrate, theoretically, in-app purchases and then link the purchase to that user. So let me show you. Let's go to my RevenueCat, which is something I already have integrated into my application from my app. And I can then also go to lovable.despia.com, which gives us specific Lovable documentation for Despia. And we could now use this logged in session to integrate with RevenueCat. So I'm just going to add RevenueCat inside of here. So I'm going to copy that, the prompt here that we have on the Despia documentation. So you can add in-app purchases now that the user is logged in into their successful session. I can go to Lovable and paste this. Now on this part here of the prompt that talks about the pricing, the tiers here, I'm just going to say that it should do a one-time purchase of credits, right? So let's say product catalog, and I already have a product added inside of here. That's a purchase, right? Okay. And now what I'm doing is I'm going back to Lovable and I'm putting this inside of here. And now I'm going to add to the prompt the purchase gives users 10 coins. Set up the webhooks to add coins to the user's logged in account, please, in Supabase via RevenueCat webhooks. And now I'm going to say, I need one webhook listening for all RevenueCat events when done, give me the webhook URL to set up in RevenueCat. And then let's also say the Supabase user ID will be the external underscore ID for RevenueCat. So the RevenueCat users, which are generated anonymously because these stores keep the users anonymous, will be then linked to the ID. So we can link an ID to the RevenueCat initialization process that comes from our Supabase ID. So when we get the signal back to our server as a webhook, we'll be able to identify who made the purchase, right? Because otherwise it's quite sucks not knowing who purchased, because then you can't give them the 50 coins or the 10 coins, right? So let's send that. And if you want to learn more about how to set up in-app purchases, I do have a full video here going through all the basics. But if you already have it set up, I want to show you today how you can then tie this to your authentication so that you know who purchased, who paid, and you can build a full, nice native experience that is pretty nice and has pretty high conversions because you're using those native Apple modules that just are proven to work. So let's approve the database changes that it suggests. Probably take a look at what it tries to do. It probably tries to do a linking table with user coins. Yeah, that's what it's doing. That looks good. Okay. And then it just relates the coins of the user. And now it creates the RevenueCat webhook. So while it creates the RevenueCat webhook, we can already go to our RevenueCat account and we can go on integrations and we can go on webhooks. We can add new webhook, and I'm going to call this Supabase/Lovable. And then I will put the hook URL and the authorization header. So now let's wait till it does all the changes and it displays the coins on the homepage, and we can then do some in-app purchases and see how the coins update. There's one more element that needs to happen with RevenueCat is we need to actually set up WebSockets. So whenever coin changes happen on the back end, the front end will be alerted that there was a change. That is probably the last thing, because when it's implementing what it currently implements, there is a high chance, I will be willing to bet on that you make the in-app purchase, the coin still stays at 0. You close the application, you open it again, and then you see there are 10 coins, which is not something we want to do, but it's something that we can solve with WebSockets. WebSockets are the reverse of a webhook. A webhook sends data from one server to another server. They're letting communicate servers with each other, meaning RevenueCat can talk to Supabase, where a WebSocket is a server talks to the front end, which usually is the reverse of an API, the front end talking to a server most of the times. So it's a cool approach because it allows your backend to ping in real time your front end when changes occur on the backend without initializing or waiting on something. So now it adds the components, it does the Despia RevenueCat user ID, product ID. That looks good. It does the initial purchase. Here's the webhook. So let's copy this webhook here. Let's go to RevenueCat, put the webhook in here, and now we need the RevenueCat authorization header value for security. I like doing it by just doing a UUID generator. There's a cool tool online. Take a random UUID from that tool, put it inside of here, and then that's it. And then you do both production and sandbox. You assign it to your application, and you just do all events. And now you add that webhook. Okay, now we got that nice send test event. We can take a look at that later on. So now we go back to Lovable, and we said, perfect. It's integrated. Now, but we need to add the RevenueCat HTTP header for the webhooks to secure them, right? RevenueCat allows you to add a secret header to the webhooks that then only your backend knows to verify that actually RevenueCat only called them and it's not the user in the terminal trying to call your server getting stuff for free, right? So let's say here is the key. and then we're just going to give it the key. Probably we should just send it like this and let it input that on the save field, but it's just for demo purposes only, this video. And I hope so far this implementation guide is very helpful in setting up authorization, and then also taking that authorization that Apple grants you, attaching it to purchases, attaching it to user activity, to create this digital blueprint or this digital fingerprint of your users, so you actually know who to fulfill in-app purchase orders to, right? So perfect, I've secured the RevenueCat webhook by adding HTTP header validation. Okay, fantastic. This sounds great. Perfect. Let's say now that we have that, we need to update the UI when webhook changes on the backend occur. For that, let's use Supabase webhooks. So when a user, based on the RevenueCat external ID, so when a user based on the RevenueCat external ID gets an webhook event, we are updating / refreshing their data on the front end. And no, I don't want to paste that. Okay, let's go into chat and let's have it first come up with a plan for that, because that is probably a little bit more of stuff that involves complexity. Perfect. So it will say, I will help you set up real-time updates for when RevenueCat webhooks modify user coin data. Let me first examine the current implementation to understand how the coin display works, and then plan the real-time integration. Let me also check if there are any existing real-time configurations. Now I understand the current setup. Okay, now it sets all of that up. Let's first publish and let's see what happens. I'm always up for an experiment. And then while it's published, security warnings just go up. We probably want to fix them once we're done with everything. But now it's updating everything. We can now implement the plan here. And while we have it now updated, let's close the application here. And let's try paying for some stuff, right? And let's see if those events properly happen. So right now I have 0 coins, okay? And I can buy 10 coins. And now I go to RevenueCat and I can buy 10 coins for $7.99. And I can do the in-app purchase. The in-app purchase was successful. So now let's look into RevenueCat. Let's look at overview. You see that there was just an in-app purchase with this customer ID. If I go to Supabase, to my authentication database, and look up this ID, you will see that this ID is the same like this user record, which is me logged into the application. And now I need to look into my database, and let's look at my tables here, and let's look at user coins. Look at that table here. Oh, how do I, schema visualizer functions, trigger, oh, they changed their UI. Let's see. New column. Oh, there you go. I think table editor is a thing I want to look at. Yeah, there's nothing in the table yet. So the webhook didn't actually hook correctly. Okay, so that's something to look into. Lovable, if I now refresh the balance, right, you'll obviously see that because the webhook didn't correctly fire, that, it's not happening. But we just are going to approve the real-time setup, and then we are going to go back into fixing the webhook that needs to be set up correctly with RevenueCat. Now, we can look into Supabase and we can look into our edge functions here, and we have this RevenueCat webhook. We can take a look at the logs, and we're going to see that there is this RevenueCat webhook, but what we're getting here is RevenueCat webhook unauthorized webhook request, header, and all of that. And what it gave us some metadata here, and we can take a look at the raw data, deployment ID, RevenueCat webhook, level info, and all that kind of stuff. We can also take a look at that webhook here, and that is also RevenueCat webhook received, the event message. We're getting the metadata here, so we have the webhook communicate to us what's happening. But the problem is we're not getting it's unauthorized, right? So that is the problem. It's unauthorized webhook request. So we can just go to the details here, and I think we got something new here. RevenueCat told us a little bit more stuff, which the webhook is being called. It's just not being authenticated successfully. So let's copy that. And now that Lovable fixed the code, let's say the webhooks get called from RevenueCat, but my backend is giving me this error. Okay, and then we'll just put the error in there that we got from Supabase. So I'll take a little bit. And, I do think it kind of like messes up the auth header, because I think there is probably a typo. Yeah, you see how we are expecting the bearer format, but they're not putting bearer in there. It's always the simple, stupid stuff. So looking into the backend on what's actually happening and reading the logs and then just copying the error that the backend tells you and putting it into the AI model is like 99% of having a skill set in building successful AI applications. So I think that'll do it. So let's make sure we publish everything. And let's try again. Let's see if future in-app purchases, hopefully now, work correctly. So it's updating it on Lovable. Let's open the application. Let's try doing some in-app purchases. Now, thank God I'm doing the test with a consumable product, letting me, iterate many times through a test purchase. But let's do the in-app purchase. It was successful. Okay. Let's see what happens on the backend now. So we can go back into our edge function. And now we will hopefully see some success messages. Webhook body received. This was successful. This is great. Okay, so the webhook was successful. Okay, webhook received. There are some webhooks that happened. Let's look at the table editor. Let's look at the user coins. It did not add the user coins though. So I think we probably have some errors linking the webhook with the actual purchase. So let's say now the webhooks work and do not cause internal server errors, but I don't see any new coin records. And I think it is because we're not successfully getting the ID information for the Supabase user record ID from the webhook. I assume it's because we are not successfully getting the user ID, external ID, which relates to our user's row ID
from the webhook that RevenueCat sends to us. Please look at the Supabase logs and come up with a plan to resolve this issue, right? And then let's go into chat mode so we can iterate with ideas, and I can give my input, AI can give its input, and we can come up with a plan to implement this 100%. But we're halfway there. The webhooks are being received. Now we just need to look into the webhook, take a look at the data, and see how this data relates. Now, because I just don't want to be this idiot here just like assuming that AI does everything for me, let's look at the logs here and let's see what RevenueCat is actually sending to our backend. And for some reason, there's a shutdown call here, but non-renewing purchase. That looks like a good one. Okay, so there is a non-renewing purchase. That doesn't help us because that doesn't give us any IDs, right? So we have this event ID also inside of here, but it doesn't give us, I don't think it doesn't give us the other event data. But we also have this event here, webhook body received, where we see product ID, aliases. This alias, that is actually our original app user ID. Yes. So you see original app user ID, that is the ID that's in our database. If I copy this ID, original app user ID, and open RevenueCat, open Supabase with the authentication table in a new tab, you will see that this is the user ID of me here, right? That is the user ID. So if it still doesn't get it, it should take the original app user ID that is being sent to it as a reference for the actual user record. I think it came up with the same thing. Non-renewing purchase, grant all webhook entries, only grant coins for initial purchase or renewal. That's why logging in RevenueCat transaction ID. Let's add to it. Also, you get the user ID that is the row ID of our auth record row from the webhook key, and we're going to put the key in there, right? So again, most of the times it's just being curious, looking into the actual data that's being sent to you, right? And then you can just, give some hints to AI, so you can make sure that it actually understands the full context of what's happening inside of here. So I need to examine the webhook logs and understand the current webhook structure to see how we should extract the user ID. Let me check the recent logs and the current webhook code. Analysis of the error. We're not handling renewal and all of that correctly. User fields, event.appUserID line, but based on your feedback, we should be using, yes, because app user ID is an array. So there could be multiple ones where original app user ID is the ID directly related to the checkout. It's the original one. And that is a more stable way, probably less prone for AI to cause errors because essentially they're the same. The original one is just probably a better way to implement that. Okay, we'll see. Let's try implementing the plan, and that should probably solve most of our backend troubles. Let's also look again on the structure here when we do the, it does the aliases, right? We have the original app user ID. I don't see, though, anything in this webhook that is app user ID because I only see aliases, I see purchase. So let's try actually in here copying this ID and let's look for it on the page, right? Because Lovable told us, let's approve this change so it can work while we're understanding what's happening here. It says there was event.appUserID, right? So when I go in here and look app user ID up, there is only original underscore app user ID. But if I keep looking for it, again, there is only original app user ID.
But, oh, no, there's also in another event here. Oh, it's all the way on the side. There's also app user ID. So I did not see that. So we can actually probably also just take app user ID. We don't need to do original one that had the first session initialized with it. We can revert back to that. Okay, let's say, let's use app user ID. And I think that is probably going to be the last change that we need to probably do for this to get working. Let's see. Let's use app user ID, but we can already test this because both will pretty much do the same thing. So let's try that again. It's updating it. There's one security error. We will probably need to review that if it, finds it out right here. But it was updated. So now we're going to go back to our application, close the application, open the application, and let's try doing another in-app purchase. So let's buy 10 credits. It's now opening RevenueCat. I'm going to do the Face ID. And now, as you can see, we got 10 coins added. So it worked successfully. The purchase went through. So if we now look into Supabase in our table editor, on our user coins, there were 10 coins added. Boom. So that in-app purchase now worked. And if I log out of the application, right, it's still there. I can buy another 10 coins. Right, let's scan my face. And now we're, doing okay. And now we're using webhooks to update the UI. We should get 20 coins. And you see how it just now upgraded to 20 coins. So there you go. So now we actually added it using the webhook from RevenueCat to Supabase. And then we're using the WebSocket when those things change in Supabase to communicate this to our Lovable application. So that is the way you want to set this up. Now, if we sign out of the application, right, and open the application again and log in with our Apple ID, right, which now works beautiful and already says that we already have an account, so it's a even nicer experience. You can now see that we got a very funky loader, but my credits, my coins are tied to my account. So when I lose my phone and get a new iPhone, because it's not related to the device ID, but to the actual Apple ID, that is the Apple iCloud ID of the user, those coins, you can use them on your iPad, you can use them on your Mac, you can use them on your Apple Vision Pro, because you can actually build with Despia Apple Vision Pro apps using Lovable, iPad apps as well. On your iPhone, if it gets stolen, if you lose it, it works on a new iPhone. Because now the purge is not related to the device ID, but it is actually related to the iCloud ID, which is a more global way. And to be more precise, it's actually related to the user's email because of the way that we have set this up with AI. So now there is another thing that we want to probably do, and that is our security check. So oh, that security check disappeared. I think that might as well just did it, right? Okay, so now there's one thing that we want to do is we essentially want to be able to, also relate the device ID to the account and the OneSignal player ID to the account. So I can send a push notification to them. So here's what we want to do. Let's say you can access, and actually, I have to hop on a meeting with the Lovable team right now, so I'm going to make a cut to this video and I'll be back in a second for you. So we're back, meeting with Lovable went well, and now let's make sure that our Supabase database also works well. So inside of here, as you can see, this is now related to the user ID, but there's no way how we are relating this to the Apple ID, which is still critical. Let's say when I log in with Apple, I have the option to link the sign up possibly to a different email. So we also want to have some sort of referencing it with the Apple relation. So the ID that the iCloud record itself has. So let's go into Lovable chat mode so we can plan implementing a solution for this possible oversight if we don't resolve it to make it secure. So let's say I assume that we
need to relate the
user record
also with the Apple Auth ID that stays the same if they log in under a new email linked to the same Apple account. My fear is that they change their iCloud email and log in under a new user, even though they are already with their Apple account in the database. Okay. Now, it could be that my fears are wrong, but let's talk about them with Lovable to have it understand my concern and then either tell me, no, you're fine, you don't have to worry about this, or come up with a strategy to improve this. So it says you raise an excellent point about user identity consistency with Apple sign-in. Also applies to Google, Facebook, anything. This is indeed a common issue with social authentication providers, where users might change their email but still be the same person with the same ID. Let me examine the current Apple authentication setup to understand how we're handling this. So it looks at that. Now, let me check the current profiles table structure. Perfect. I can see that you already have an Apple user ID column in the profiles table. And looking at the Apple Auth function, I can see that it's already designed to handle this exact scenario. Okay, let's say, what if I log in under a new Apple email, same account? Will the user row ID be the same? And let's say, is it safe to use the user row ID as the primary user auth ID? Does it relate to the profile and attaches a new email to the user row if a user logs in with a existing profile, but an email that is not in the user table, right? So my fear is, let's say I log in and I have this one ID 123 that is my Apple ID. And I'm now logging in under a new email with the same 123 Apple ID. Will I still be related to the original user record in my database to the first email I used to sign up with? So let's have Lovable take a look at that. It says, let me analyze the current Apple authentication flow to understand how the user IDs are handled when someone logs in with a new email, but the same Apple account. Based on my analysis of the current Apple authentication flow, here's what happens when with user IDs when someone logs in with a new email but the same Apple account. Current behavior analysis. The user row ID will not be the same if someone logs in with a new email. Here's why. Current logic in Apple Auth function, lines 46 to 66. So, okay, the function checks user metadata, Apple user ID, but I can see from the database that the Apple user ID is stored in raw user metadata, not user metadata. This means if
a user changes their iCloud email, the function won't find their existing Apple account. A new user record will be created with a different user ID. They'll lose access to their previous coins and profile data. Safety of using user row ID. It's generally safe to use the user row ID as the primary identifier, but only if we fix the Apple user matching logic. The Supabase auth user's ID is a stable UUID that doesn't change. The current way to identify users across sessions. The way that what we should use for RevenueCat's app user ID. The fix needed. The current Apple authentication has a critical flaw. We need to fix the Apple user matching, check both raw user metadata, and also query the profiles table directly for the Apple user ID. Okay, so now this plan sounds good to me. Let's implement the plan, because there's a critical flaw that if I change my iCloud email, log in though with the same iCloud account, it will create a new account and not give me access to my existing credits. So we need to think about those edge cases and also make sure that they're being implemented. So let's approve this change in our database on our backend, and then we're going to have that implemented. And I think we'll be ready to battle test it. So let's see, it's thinking about how to implement that. Now I'll update the Apple auth function to fix the user lookup logic and add better logging. Okay, now it's editing and setting all of that up. And we'll see it does that inside of here. Perfect. Let's go back to the preview section here. And it's now editing the files, because what's happening here is we have the email in here, right? And what happens is, if I change my email, but the Apple account that's related to it doesn't change, it will create a new user record in this user table, right? So we're not implementing it correctly to manage the metadata. So if you can see, if I go to profiles in here, we see we have full name, avatar URL, we have Apple user ID, and now we need to look into this Apple user ID, say, hey, this user ID, which is related to it, right? This user ID with this Apple user ID in this linking table for the profiles exists, but their email may not match, but this Apple user ID matches. So let's authenticate this session because the Apple user ID matches with, the email. Even though it may not be exactly the same, but it's still the correct Apple account. So we're handling that edge case in case someone says, you know what, let me just change my iCloud email today. Rarely happens, but you want to plan for those things to happen because users are unpredictable. Okay, so now that seems to be done it. So we can just update our application now, and let's try implementing it now. So I got my phone already in here, and let's try setting that up. Okay, so still updating, takes a little bit, and we'll just wait. It's taking a little bit long today. In the meantime, we can see, oh, perfect, I don't have to cut more time. Perfect, now we can test it. Let's open the app, and let's make sure we're signed out, and let's log in with Apple. Now it's going to trigger the login with Apple, right? And as you can see, there is already an account linked to my app, because the way Apple JS works is when it runs in your application, you can't change the email, you can't do that. So, we can't really test it. We can take a different iCloud ID and see if it lets us slip through, but there is already a mechanism inside of Apple to prevent this from happening. Even though Apple prevents that to happen, you still want to implement it on your backend to be better safe than sorry. But as you can see, I got 30 coins. I got the user ID that comes from the user column database. That is how we identify the user in the session and how we relate that to the RevenueCat purchases. And then when I go into buy 10 more credits, it's now initializing the purchase. We're doing the purchase here, and now it will say the purchase was successful, and now we see that the credits have been credited, 10 more credits purchased. And that is how you add native login with Apple, and then also take this authenticated session and use it in other native functionalities inside of your Lovable application. So now the last thing is to take a look at the security scans, because, we want to make sure that we are following security best practices. So leaked password protection is disabled. Function search math mutable. Okay. Performance and let's do that. Security path mutable. Okay, let's close that. And financial transaction data could be exposed to unauthorized users. So they need to be fixed. Let's try doing an additional security check. And let's see if we can have Lovable fix most of the things, hopefully, for us to make sure that now, once we're handing off our application, that stuff is actually secure. Right? Okay, now let me say, can we implement a plan to fix this? Oh, and we need to do row-level security policies, of course. So can we implement a plan to fix this all? So it's now calling all the tools, scanning our backend, making sure that everything is secure. It's a great feature that Lovable provides. So can we implement a plan to fix this all? Comprehensive security report. Coin transactions can be exposed, so we don't want that to happen. So we need to implement row-level security. Hard-coded RevenueCat authorization key contains the hard-coded key in the source code. Yeah, we should use environment variables for that. And then missing Apple signing client ID validation, right? Implementing. So we need to have like a conditional statement, a precondition validating that, and then improvements, security, to database and functions like explicit search path settings. Okay, so let's say, can we implement a plan to fix this all? Or actually, we already have it do that, so we can even save more credits. Let's just go and implement the security fixes. And now, Lovable analyze our backend on everything that's happening, and now it can just implement and fix all the things that are security concerns. So that is a great feature and very critical when you're vibe coding, because you want to make sure that it's secure. So now we need our webhook key. I hope I can still open that and see that from Lovable, from RevenueCat. Let's go on webhooks, go on my webhook, and let's edit the key. Doesn't give me the key. Okay, shouldn't have done that. But it gave me the key before in the chat. So I'm just going to take my key, and I'm going to put this in here so it's securely saved on the backend. Okay, let's submit that. Okay, now that we have that action approved, we can continue with some of the next steps. Okay, now I'll update the RevenueCat webhook function to use the secret and fix the database functions. Okay, so now we're going to wait till we get a preview of what it's actually doing, and then we'll be able to approve the changes that Lovable did. So it's, then it's probably then just going to use the environment variables. Okay, let's approve that. And now we'll just wait a little bit more, and we'll be able to then actually have our purchase data successful. After it is done implementing the security check, we're probably going to run another one just to make sure that actually there are no errors happening, especially when you're doing authentication, when you're doing purchases. You want to make sure that everything is airtight, right? So now it is updating the functions inside of here. Okay, we moved RevenueCat webhook key and environment variables. Okay, update auth for Apple ID. So it seemed that this was fixed. Let's try updating that. And then let's already start reviewing the security. Now there's still two warnings: function search multiple mutatable, okay, and leaked password protection disabled. And then there's an error: financial transaction data could be exposed to unauthorized users. Let's try to fix this. Okay, and now let's see, financial transaction data could be exposed to unauthorized users. The coin transactions database contains sensitive financial data, including transaction amounts and payment processor IDs, but lacks insert, update, delete policies. This could allow unauthorized users to manipulate transaction records or create fraudulent entries. Add comprehensive row-level security policies for all operations on this table. Please analyze the security issue in my project and fix it if possible. Make sure this fix doesn't break existing functionality and follows security best practices. If you need to modify files, please do so carefully and explain the changes. Okay, let's approve this. Let's close that because we're working on implementing the change right now. So now Lovable is thinking about how we can make this secure, because having a pretty application isn't everything. It's also having a secure application. Okay, so now this looks good to me. So let's publish this. Let's review security again. Now there are no errors, they're just warnings. And those are settings, right, that we can implement. I think I'm good with that for the sake of having a demo video, even though you should always, set up, and follow their warnings. But for the sake of not having this video take 2 hours, even though we're close to 2 hours, we're just going to skip some of the best practices that are, they still need to be turned on, right? Leaked password protection and some of the other settings. But we're just going to skip this because it's just a demo video. But then you can just work with Lovable together on making it fully secure. But now we have it updated, so let's test the final version. I'm very excited for this. Let's open the application. And now we're going to see we're already logged in. Let's buy 10 coins. This will be now initialized based on the user row ID. I can make my in-app purchase. It will relate it to the correct user. It was successful. Now it goes to the backend, creates the entry, calls the WebSocket, and will call my front end to communicate that the purchase was made. But now, actually, it doesn't seem to work. So let's try closing this and opening it again. There could be it did work. So now the WebSocket doesn't seem to work correctly. While it's adding it, I think the WebSocket, the real-time communication, is now not passing on anymore because of some row-level security updates. So we probably need to move the WebSocket call. No, actually, now it worked. Okay. Let's try that a few more times to verify that it was actually working correctly. Get 10 coins. Okay, let's try that. Perfect. Okay. Ooh. I think it may be my internet, actually, because it took so long to open RevenueCat. Let's try that again. Yeah, my Wi-Fi isn't doing well today. Okay, now it's a little bit better. You see the status bar. Okay. Okay, now we got RevenueCat. Okay, yeah, if you click it 2 times, there'll just be an error from their SDK. But it seems to work. It just seems to be my internet that is not working that well. So there's probably some backup that we probably want to implement if there is the WebSocket connection lost. Because, right now I implemented my internet. You can see it's jumping between the bars here. And sometimes the WebSockets work, sometimes they don't. Now we want to make it more stable. Okay, now it seems to be working well. So it should now work well with my internet. Let's see. And it should jump up to be 80, even though it's added to the database, but it's not jumping up. So we'll see. So now let's say the WebSockets are not fully reliable. Sometimes they work, sometimes they do not. Okay, let's do this into the chat so we can come up with a plan, and then we're going to see if it will implement the plan, because right now it's still showing 60 coins. I have to close the app, open it again, because the WebSocket connection doesn't fully get called, or there's no fallback if it times out or something like this. So we need to look into that. Because that is a critical fix. Because if people purchase something and they feel like it didn't went through, they're going to complain about stuff. They want to have a refund. Right now it worked, but before it didn't work, right? So you want to make sure that you're building a product that works all the time. So I understand you're experiencing intermittent WebSocket reliability issues. Let me investigate the current WebSocket implementation in your project to identify potential causes and develop a plan to improve reliability. Okay, now let me look into that. Okay, based on my analysis, I can see that your project uses Supabase real-time subscriptions, which use WebSockets under the hood. For the coin display component, the intermittent reliability issues you're experiencing are common with WebSocket connections and can be caused by several factors. Current WebSocket implementation analysis. Your current real-time implementation in coin display TSX has those structural changes, common causes of WebSocket reliability, network interruptions. Yeah, like I had a little bit, browser tab, backgrounding, Supabase connection limits or temporary service issues. Reliability enhancement plan, add connection state monitoring, right? Display connection status to users, log connection state changes, implement automatic reconnection logic, detect when subscriptions fail or disconnect, implement exponential back-off entry strategy, handle authentication renewal during reconnection, move real-time logic to a custom hook for reusability, add fallback mechanisms, implement periodic polling as fallback, real-time fails, add manual refresh options for users, cache last known state to prevent UI flickering. Okay, that seems like a strong plan. And let's say, always make sure that even if new coins come from polling, to still show the toast and upgrade UI, right? So that even when it comes from a polling and not from a WebSocket, because, they can have connection issues, we're not just trying to, when we see a connection issue with the WebSocket, re-poll some of the data and try to get it again from the database, but we're also then saying that if it comes from a polling and it's a greater number than the current number or the current data that we have stored, it'll still trigger this UI update flow, right? So now that seems like a good plan. So let's finish Lovable thinking about it and implementing that strategy. And now we're going to implement the plan and we're going to test it, because it seems like my Wi-Fi is all over the place today. And then we're going to see if it works all the time and if it is reliable as it claims to be. Perfect. So now it's implementing a robust coin management system with reliable WebSocket connection and toast notifications for any update source. Now I'll create a robust use coins hook and update the coin display component to use it. So it now updates the files, sets everything up for that. And it'll take a little bit. And then once we're done with that, we should be able to test that. So let me already just close my application so we can have it refresh. And then we're ready to test this again. We can see all the files that it's currently working on. Let's look at them. Okay, updates those two files. So it should be done any moment. That's also, I got to reconnect to my phone again. It's always turning it off. Okay. So now we should be getting connection to my phone back so I can show you the updated version. And let's just do like a few app closures and opens to make sure it all works. So now let's make sure we update our application so everything is nice and all set up. I'll take a little bit, and then already let me get my iPhone ready, and then we'll be able to test this directly on the phone. So let's open that. Now, as you can see, we even have a little cool, cute UI with like the connection. So let's buy 10 credits. Let's purchase them. And now you see, okay, got 90. The WebSocket coming? I don't think it's coming. But if I reload here, it'll go to 100, right? So we need to have some automated polling. It's still not fully reliable, the WebSocket. Still not fully reliable, the WebSocket. Take a deep look. I need automatic updates to the UI. No button to press manually to see if your purchase was successful. That is bad UX. Okay, let's fix my typos here. Okay, and let's put this into the chat so Lovable can come up with a plan. And I think I have a good feeling about the last one. That'll be probably the end of that. So we'll see. Because you need to handle kind of like network instability and probably also want to use some sort of polling for like a time frame. Like, let's say you do a WebSocket and you initialize the RevenueCat purchase and you're waiting on the server to respond to it. You probably want to implement polling for like, if you are listening for stuff for like, you could do like a polling every 5 seconds to see, did something happen? Did something happen? And then if nothing happens for like 2 minutes or so, or 3 minutes, and no webhook comes, you can then kind of like quietly shut it up and then like show a pop-up message, try again or whatever. But we'll take a look into that. I think polling is probably a good solution for a certain amount of time frame after we try to initialize this, to make sure that should the WebSocket fail because of a bad internet connection, we have backup methods. So let's take a look at that. Okay, search for replica full identity. Let's take a look at the code. We're doing some timeouts. That does the Author base use toast? Yeah, there's like a 30-second. We're doing kind of like a polling. Okay. Let's see. Thanks for flagging this. You're absolutely right. We should never need to automatically refresh a purchase. It took a deep look at the current real-time setup, and I took a deep look at the current real-time setup and identified a few gaps that can cause intermittent missed UI updates even when the database is updated correctly. So this is great because we need to handle unsubscription events. So saying every time the webhook is closed or unsubscribed, we're doing some polling for some time to see if something comes and then reconnect it, right? If something comes after the webhook shut down, then let's poll, see, did something happen? Oh, something happened, show the UI, and then nothing yet. Okay, let's just activate the webhook again, right? So you need to have kind of like automated error handling in your code to make sure that it all works nicely. So let's implement that plan. I do like that plan. That sounds like a good plan. So let's close the code files here, look at our beautiful interface, and then we're going to keep working with this and then keep making improvements. So I'll implement the robust WebSocket system with automatic fallback polling and reliable toast notification for all coin updates. Now you're going to see it takes a look at the console logs and all that. And then now I'll implement the enhanced WebSocket reliability system with continuous background polling and turbo polling during purchases. That's good. That seems to be fine. Perfect. And then we're just going to use coins.tsx. We're going to edit the file. Okay, that looks good to me. So we'll just wait till Lovable finishes some of that process, and then we'll be able to play around with that. So let's see till it finishes that, and then we'll be ready to rock and roll. I'll take a look at it. But, oh, it is the next file, and now there's the purchase button. It is probably now going to implement some of the polling mechanisms. Let's see, RevenueCat, do they also give us a webhook for failed events? Let's see. There should be. If we specify events, initial purchase, renewal, product change, cancellation, no. Expiration, temporary entitlement grant, virtual currency transaction, refund, reverse. No. They do not tell us that. But, polling seems to be a valid method because you're just waiting till a connection was established and you're getting a response back from RevenueCat. We should take a look at the RevenueCat SDK probably allow, or let's see, we can probably do a promise resolve in the RevenueCat SDK for Despia, and I assume there must be some native event that RevenueCat gives you if the modal closes, so we can implement that when the modal closes that you're stopping the polling, but that's something we actually have to add to the Despia integration with RevenueCat. And that's something that I will put right now on my to-do list. But let's take a look at that again, and let's update that, because I think the way we currently have it implemented is pretty fine by itself already. So let's see. Because what we're doing is we have now enhanced error recovery yet. That is, I think, why most of the stuff is a little bit janky. So let's try closing that and opening the application again. Let's make sure that the WebSockets also have appropriate polling. So you see it's still saying connecting. If I reload this, I'm seeing that it still tries to connect. So this is something I should probably mention to Lovable. Let's say when I open the app, it says connecting the whole time non-stop. And let's send that. Okay, now it could be that it's just the UI that's funky, so let's try buying 10 coins. Let's do the in-app purchase. And now it does actually work pretty well. Let's try that again, because I don't believe that this is working good. Let's try that again. Okay, let's try doing the purchase again. I can do this the whole day. Oh, my face didn't went through. Try that again. Oh, that works like a charm. 3 is a charm, so it works already like a charm, but let's try it a third time, so it's a double charm. Let's try purchasing something again. Okay. Oh yeah, that is nice. That works well. Now, this seems to be working very great. So let's see what Lovable is thinking about here. And then I also want to put a prompt and say, make sure that we're doing this very memory efficient. What we're doing is not like, we're not just like calling stuff a million times after each other and all that, which is something you do have to note because sometimes that happens. Happened to me a few times. So always double check on those things. But now it's reading a bunch of our files and taking a deep look at some of them. And let's see. It's going to still think. So it's going to give us probably a plan to improve some of that stuff in the chat. Okay, iPhone is connecting again. Okay, thanks for your clear signal. I can see, scroll down, I can see why you're getting connecting indefinitely, what's happening. The use coin hook sets the connection status to connecting right after subscribing. In some edge cases, the subscribe status callback never fires, no subscribed error closed, so we never flip to connected or fallback. Because we only set a no event watchdog after subscribe, there's no timeout for the initial handshake result. A connection handshake timeout 7 seconds. If we don't receive a subscribe status in time, we mark the connection as failed. Okay. Troubleshoot docs, and it even gave me a diagram. Oh, that's cool. That is cool. So let's say, make sure we follow best practices and we are not putting too much weight on the app itself. Also, you can remove the status UI as it was only for debugging. And let's enter that, and let's have Lovable come up with a plan so we can chat back and forth with it. And then once we read through it and makes sense to us, we're going to then implement that plan following their suggestions. So it says, I understand your concerns about performance and the debugging UI. Let me examine the current implementation to identify potential issues and optimization opportunities. I can see several performance issues, of course, and areas for improvements in the current implementation. The user is on the auth route, which suggests they might not even be authenticated yet, but the WebSocket and polling is still running. Here's what I found. Okay, there's some stuff that we definitely, aggressive polling, memory leaks, redundant status UI, toast spam, heavy resource usage. That's why you do those prompts, so Lovable has a better way of doing those things. Okay, let's do implement the current plan. And then we're just going to have that set up nicely. So I'll implement the performance optimization plan by removing Debug UI, optimizing polling, and adding smart resource management. That sounds great. Actually, I think we can actually top this by even sending them a push notification when their in-app purchase was successful, so we don't need to have the ugly toast. So we can actually do a real push notification with OneSignal. So we'll also do that. Because if we're already doing it, we might as well just do it right. So let's have it now implement the plan. Now I'll implement the optimization plan by creating simplified, efficient versions of both files. That sounds good to me, so we'll just wait. And in the meantime, I think we can already look into setting up OneSignal for some of that stuff. So let me get my phone connected, because it temporarily loses sometimes connections with the screen mirroring, so I can share some of the native stuff happening to you. Let's see. Yeah, it's coming through. Okay. And then while Lovable is doing that, let's go to OneSignal, right? And I already have it set up, but we also do have videos step-by-step showing you how to set up OneSignal and all that stuff. But as you can see, I already have my application here in OneSignal. And what I just need to do is I just need to go to settings and get my keys and IDs. And I'm taking my OneSignal app ID key to use it to send push notifications to the users when those purchases happen on the backend. That's actually probably the best way to run that. Okay, to notify the user that something happened, and then we're just doing polling for the other stuff. We'll probably implement silent push notifications to Despia, meaning every time you get a push notification, you can run a function to recall more effectively data from the backend, kind of like as a hook. So that's actually a good idea. We should look into that. We'll be able to add that pretty fast. So let's look into this. Optimize the coin system with 80% less resource usage, remove debug UI, added route-aware initialization, and refined polling to 30-second intervals with smart toast notification system only for significant changes. That sounds too good to be true. Let's try updating it and see if it is too good to be true. Okay, and then we're going to add push notifications to it to really complete this beautiful native application. Can you believe it? We just built a native mobile app in like 1 hour with Lovable. Technically 2 hours, because there was some debugging and there were some best practices. So we built the app in 1 hour. We made it secure in 2 hours. How about that? So let's buy 10 coins. I really like seeing the UI. It's just beautiful. Let's try buying the coins. Okay. And now, as you can see, WebSockets not really sucking. I probably will take up to 30 seconds to do the polling because the WebSockets are not really firing. I wonder why that happens. Let's go back and let's say the WebSockets are not really working at all. The WebSockets, I mean, it did work now after 30 seconds. But it does, because it does the polling. The WebSockets are not really working at all. And we need to be a little bit more precise. I want to listen for WebSocket events on the index main app page for subscription changes, for purchase changes, and also really tune in after the purchase button was clicked, and if after the button was clicked, and after the button was clicked,
and the WebSocket connection failed, do an API call to check if purchase changes happened, and if so, trigger the logic like a purchase, and also before that reconnect to the WebSockets. Do this for up to, and now this is good measure, for up to 5 minutes after. Do this more aggressive method for up to 5 minutes after the purchase init low, and stop the aggressive one. Stop the aggressive one when the purchase was confirmed on the UI, plus, but always keep the sockets alive for events possibly coming from other devices triggering the but keep socket alive for events even I didn't want to tap on there, even after the main event listening. Okay, let's send that. Okay, let's try that. I think that I have a good feeling about that one. Let's see. It's now thinking about the implementation plan, and we already got OneSignal set up. Now, I did this in another video, so if you want to take a look at how to set up OneSignal, make sure to watch the video. But since I already have it set up for the application by just going into Despia, right, and going into OneSignal and dumping in my app ID in here and rebuilding the application, right, we'll be able to then send them a push notification, and then possibly, or 100% likely in our next update, also do silent push, meaning you can do a push notification that will trigger your app to do an API call and check and verify stuff. That is probably even more reliable than WebSockets in an application, and we're going to have that added. That's why we do those videos, to see what is, it's not 100% perfect, nothing is 100% perfect, but it's all about knowing what you're not perfect at so you can improve it, right? So let's see, Lovable is still thinking. I think it has to do lots of thinking to digest what I just told it. So we're just going to wait a little bit, and in the meantime, let's already pull up the Despia Lovable documentation. So let's do lovable.despia.com, where I have the beautiful OneSignal integration on there, and I can already get ready to copy the prompt, right? So it will need to relate that, so we can already select that text and check. Oh, Lovable is still thinking. So how about I copy this and try reloading the page? There may be something going on with their AI. Let's see if it starts. Let's stop the AI then. Okay, this message was canceled. And let's send that message, and let's keep the window open and
let's see if it will be able to give us a response to the changes that we want to implement. But in the meantime, we can, no, there's actually nothing that we can do. We just got to wait on the AI to come up with a response for us. So I would call this a live build today. It started as a tutorial, it's ending as a live build, but you know, that's how you do stuff. Let's actually check the inspect and the network tab. I'm curious. Lovable is still fetching resources. I don't know if it does the dev server, but that's the sandbox environment. I don't know if their AI is working at this moment. I mean, it's reloading some of the stuff. I think there may be like a thing happening with Claude. Sometimes things happen with Claude. So let's see, that message is still open, so it should try to reconnect with that. We'll just wait a little bit, and I'll probably make a cut and let you know once the AI is back up. So Lovable is back online. So now it's saying, I will add a new hook to manage robust WebSocket monitoring with a 5-minute aggressive fallback after purchase initialization. Wire it into the index to listen on the main app and keep sockets alive afterwards. I'll first read index.tsx and the latest logs, then implement the hook and minimal index edits. Okay, now it's reading all the files, it's editing some of the files, it's thinking about some other stuff. So it does that now, and it's editing the index file. So let's take a look. That's nice. Okay, let's take a look at, I was not doing changes in there yet, so take a little bit to see all the changes that it successfully made, but we can close this for now, and we're just going to wait till it implements that, and I can then already get my next prompt ready, which will be implement this OneSignal UI, OneSignal player ID binding. Okay. On app load for logged in users, please call an API that we need to create called /hardware/sync, /hardware/sync, that will receive the Despia dot OneSignal player ID, OneSignal player ID from variable of page that has where did I stop writing? That has Despia native installed, on page that has Despia native installed, and relate that player ID to the user in a linking table. When the user upgrades / does the RevenueCat payment event, initial payment, meaning we're doing the first payment, send a push notification to all the users' player IDs stored in the database table, confirming their
purchase.
Here are the docs to implement OneSignal using the client side, Despia SDK, and server side OneSignal API. Here are the docs, and now I'm just going to go to lovable.despia.com, copy the prompt that we have inside of here. That will give Lovable exactly what it needs. It's 100% battle tested, and put this inside of here. And now, because I don't know if it still works, I'm just going to copy the whole prompt that we just wrote. And we're going to test this version here and see if that works. I have a good feeling about this. So let's try that. And we already have the prompt with Lovable and OneSignal. So we're in good timing today. Perfect. Let's try opening this, and let's try opening our application. And let's see if in-app purchases now get beautifully registered. So let's buy 10 coins. Let's do the purchase. Okay. Oh, yeah, that works amazing. Look at that. That is snappy. Let's close that again. Let's do the purchase again. Again, we need to test this 3 times because 3 is a charm. Let's buy 10 more credits. Do the purchase again. Okay, should go to 160. Yes. Ooh, that is nice. Okay, let's try for last time. Again, 3 is a charm. Let's do that again. Buy 10 more credits. I can purchase this the whole time. I just love how the numbers in my RevenueCat keep going up, even though it's test mode. And now we're at 170. So this works perfect. So now let's implement notifications. This is even more exciting. So let's send this prompt to Lovable that we just created to initialize in-app, notifications with native remote OneSignal powered push notifications for important events such as purchases. So just like this. And then we'll be able to get those beautiful in-app purchase events. So let's see. I'll implement OneSignal push notifications with player ID binding and purchase confirmation notifications. Let me start by checking dependencies and creating the new database infrastructure. Let's approve the change on the backend that Lovable wants to do.
I really like this. This is pretty cool.
I could do this the whole day. And now I need to add the OneSignal secret. So let's take the OneSignal app ID. So we go to OneSignal and copy the app ID. And we're going to put it right inside of here and submit it to Lovable. Now the next thing it wants is an API key. So I'm going to add an API key called Lovable Supabase, right? And I'm going to create. And I'm going to copy this. I'm going to put this inside of here. This video started as building login with Apple, and it did end in building a whole Apple iOS application in Lovable. But I'm all for it. Okay, so now let me create the edge functions. First, the hardware sync function. Okay, that is very cool because now we're going to take the Despia.OneSignal player ID. I hope I wrote that correctly, but I also did paste the documentation to get the ID client side, then sync that with the backend, keep track of all the player IDs related to the users, and then when the user ID in the database has a purchase event happening for them, we can then, using the OneSignal server API, send a push notification to all their devices that they just made a purchase to confirm the purchase from the server webhook event. So that's how you're doing full stack hybrid application development here in Lovable. So it says now let me create the edge functions. First, the hardware sync function. So it made 2 functions, I assume. And then now let me update the RevenueCat webhook to trigger push notifications and integrate the hardware sync into the index page. Now, let me add the hardware sync call onto the index page. I want to look at that because I want to make sure it sets it up correctly because, there are always some ways how it can mess that up. So I need to import the Supabase client, so it imports the Supabase client, so you can probably get the authentication data on that page. Perfect. I've successfully implemented the OneSignal push notification system with player ID. That sounds promising. So let's look at this code here. So as you can see, it does a Supabase thing, Supabase URL, anon key, it gets those secrets, hardware sync. I'm more interested in the file that actually calls it, that runs client-side. So let's see, that's the index tsx. We added that, and then we added the hardware sync. So we're doing access OneSignal player ID from Despia. We're doing Despia await import. I assume it's not as good as like importing Despia like this, but I do think you can actually import Despia like this. It should work because it allows on npm also asynchronous imports, and then it gets Despia the default OneSignal player ID. That does not seem right to me. Let's say the player ID is, no, that doesn't make sense. The player ID is available under Despia.OneSignal player ID. Always make sure that it uses the Despia methods correctly. And it needs to be imported on the page like this. Okay? And then let's go to the documentation here and let's call how it has to import that. And then let's say, follow this very closely. And then do not make stuff up. And then I can also say, to get even better results, if needed, reference this npm docs. Doc for the Despia SDK. And then we can just go and copy here the link that we have for the npm package that essentially tells Lovable how this whole thing works under the hood. And we're already at 1,251 downloads. It's going great with that package. Beautiful. So let's put that inside of here and let's send that in the first week. I think that's really nice. Perfect. So now I'm sending this and it will now set up the code correctly. Because Despia.default is not something that exists. So, AI is great. It's just not AGI yet. I can't wait till we have AGI though. So it will make sure to get those things right. Just give us a few weeks. We'll get it. We'll get there. Okay. You're absolutely right. Let me fix. I love how always AI says you're absolutely right. Yes, you're the smartest. Let me fix the implementation to properly install and import the Despia package. It installed it. That's good because you need to install it to use it. And now it's editing the files. It's now doing npm install. Okay, let's look at the code. Okay, this import statement is 100% correct. I can tell you that. And then OneSignal player ID doing Despia.OneSignal player ID is 100% correct as well. Perfect. And then let's say for debugging also show the player ID in an input on home page like you do with the user ID. Right? Remember, on the application itself, we have this user ID here. I want to do the same thing for the player ID so we can verify that there is a player ID that is available to us and that we can access it and then it's being set. And it's using the correct methods to do so. Because if we see it on the front end, it will also be successfully sending it to the back end. And then push notifications will beautifully work in this example. So it seems like it's doing that. Let's look at this here. It imports it. It gets it from Despia.OneSignal player ID. Yeah, that looks good. Let's update this. Now it's updating the whole thing. And let me already, that's how you do
over-the-air updates, close the app, open it again, and then we'll know what's happening here. So, moment of truth, we got the OneSignal player ID inside of here. So, let's see if it works on the server. Let's buy 10 credits. We're doing the in-app purchase with our beautiful face. And now the coins was successful. Coins should be getting up. Yes, 180. We got the alert. And now because I'm sharing my screen, I'm not seeing push notifications, or you're not seeing them. But they are there. You see, purchase confirmed. You've successfully purchased 10 coins. So we just got the push notification. If I click on it, opens the app. I can also set it to go to a specific page in the app. You know, you can just reference the documentation for that. OneSignal is very flexible. But there you go. That is how you do it. Let's test it 3 more times, because you know 3 is a charm when it comes to application testing. Buy 10 credits. Let's do the purchase with RevenueCat. Okay, it'll go up. Perfect. Let's try that. Close the application again. Try that again in a new session. You know, always do some, really, powerful testing, rigorous. Let's do more purchases. Okay. Now we're at 200. Let's scroll down. You see we got 2 push notifications confirming our purchases. Now let's look at the warnings again. Edge functions could access all user device data. Okay. LLM database breach. User database table has a policy allowing edge functions complete access. Yeah. Okay. Let's go to Lovable. That is something we need to fix, because we shouldn't give everybody our player IDs. I mean, it doesn't really matter, but you should be mindful about user device data. Let's say fix this. That is a critical thing that is even worth fixing in a video. Let's start this in the chat so Lovable can, reason a little bit more, understand the problem deeper, come up with a better plan, and then we're going to test that again, and then I'm going to let you off for today. But we do need to make sure that row-level security is implemented. That is something that is very important for Supabase to keep your backend secure. So now it's reading the functions. It's going to implement that on the database level and searching for user devices. It now has an understanding of how it does it. I highly suggest everybody who thinks Lovable, what's that? I tried it 6 months ago. It's absolute garbage. I said the same thing a few weeks ago, and I tried it again. I'm blown away. Like, security, very well handled. Updates, very well handled. Credits, pretty well. Like, I just built a whole application for like 50 credits. Like, good luck trying to find a developer who's going to build this for you for $25, right? So you can make incredible progress really fast for cents on the dollar, really. So let's approve that. I'll still make the preview. And then we'll just wait a little bit to get it all over there. Okay, let's approve. That'll take a little bit. And then let's approve some other database changes. That should get rid of the row-level security errors. I would actually argue they should be on the warnings tab, not the warning. It should be on the danger tab, because that is very important stuff. So let's wait for that to reason. I'm going to approve the actions. Now I'll update the edge functions to use the anon key and security identifier function approach. Perfect. Let's show all. It'll update the functions now. And let's just look again at those beautiful in-app purchase confirmations. Purchase confirmed. You've successfully purchased 10 coins. How amazing is that? Beautiful. Click on them. Go back into the application. I think it's beautiful. Wonderful. And then let's go. Security improvement successfully implemented. Okay, that's good. Now the fact is that we have those security improvements made and the changes are done. Let's update the application. Yeah, it went down. That one
more important warning. The other one's not too important for a video. It's now updating it. Now I can close the application. I can open it again. We can try it for another 3 times to do some test purchases. This is why I always recommend to do consumable products. Yeah, 210. Let's try that again. 10 coins. And now we're at 220. Yeah. Let's close that again, start a new session. 10 coins. Another native in-app purchase, 230. Yeah, 230. That was successful. Fantastic. And then if we sign out, we're out. If we close the application, we're not going to be logged in back into it. We need to continue with Apple. That shows us the native modal with a beautiful preview image here. I will do my Face ID to log in. 1 click, I'm in. Super nice, super easy. Loading screen can be improved, but there you go. And then I can purchase even more stuff. We love doing in-app purchases here. And now it goes up to 240. Just like that. And now we see all our purchase confirmation, native server-side send push notifications. I can click off them, go into the app, or you can set it up with the OneSignal REST API to go to a specific dynamic page of your application. So that is how you build an iOS application, and everything we did today is one-to-one the same for Android. Besides login with Apple, obviously, they're not going to be too happy about having an Android app with login with Apple. Just do the same thing with login with Google. Same principles apply to everything. iOS, Android, any OAuth provider. We build a native OAuth-based application with native functionalities for in-app purchases. Or one thing to note, when you do in-app purchase and you want to do a purchase again, what you need to consider is you need to reset the application or reload the page to do another in-app purchase, because the RevenueCat API is preventing people from clicking the button 2 times and accidentally doing 2 in-app purchases. So you can just do, after the webhook success was made, just reload the page or run the native app reset API just to clear the state of the in-app purchase SDK. And then you'll be able to do another in-app purchase, because most of the times you're not going to buy 5 tokens and another 5 tokens and another 5 tokens. So you can just refresh to then show that accordingly to just refresh the state of the page. But, this is kind of like a prevention mechanism to protect you from angry customers. But then they can purchase more credits, or you could just reload the page to refresh the state. And then you can do more in-app purchases. But that is it. That's how you implement native login with Apple, the native login dialogues with Apple JS with the SDK. Then link that to Supabase to store your users, save those sessions, link it then to the Despia wrapper function for the RevenueCat SDK, giving you access to do native in-app purchases, implementing webhooks on the backend, connecting RevenueCat with Supabase, and then using that with Supabase real time to update the UI on the front end, handle things like offline connections, all that kind of stuff, and make it memory, effective, so the application runs nice and smooth and all that kind of stuff. So there you go. That's how simple that is, how simple that can be. And we're going to make even more videos about how to build amazing applications inside of Lovable and Despia on this channel. So make sure to give a like and a follow. Thank you for watching this video, for going on this roller coaster ride with me together and building an application, a native application, no cuts, no preparation behind the scenes, with the power of Despia and Lovable in just under 2 hours. It's remarkable what you can do nowadays with AI. This would have took me at least a few days if I would do this manually with other solutions. So I think it's the future of development, especially when it comes to building prototypes fast, and you don't have to compromise on security anymore when you're using Supabase and Lovable together with Despia, because of all those amazing features that I didn't even know that they already shipped to make it just a great experience to build applications fast. So thank you so much for watching, and see you in the next video. Take care. Bye.